Section 5 AWS Integrated Services. In this section, we will learn the following topics: Elastic Load Balancer, AWS Lambda, Autoscaling, AWS Route 53, AWS Relational Database Services, AWS Elastic Beanstalk, AWS S&S, Amazon CloudWatch, Amazon CloudFront, AWS CloudFormation. Video 5.1 Elastic Load Balancer. In this video, we will cover the following topics: What is a load balancer? Difference between the application load balancer and the network load balancer. Use cases of application load balancer. Features of application load balancer. What are listeners, targets, and target groups in a load balancer? Demo of application load balancer. Hello. Let us now learn what load balancers are. The Elastic Load Balancer, or ELB, helps to manage and control the flow of inbound requests destined to a group of targets by distributing these requests evenly across the targeted resource group. These targets could be a fleet of EC2 instances, Lambda functions, a range of IP addresses, or even containers. The targets defined within ELB could be situated across different AZs or placed within an AZ. Advantages of ELB: It is managed by AWS and it is by definition elastic. Automatically scales the incoming traffic. High availability and robust security. Load balancer types: Application Load Balancer, or ALB, Network Load Balancer, or NLB, Classic Load Balancer, or CLB. Application Load Balancer, or ALB. It provides flexible feature sets for web applications running the HTTP and HTTPS protocols. It operates at request level. It provides advanced routing, TLS termination, and visibility features targeted at application architectures. Network Load Balancer, or NLB. This is used for ultra-high performance for your application with very low latencies. It operates at the connection level, routing traffic to targets within your VPC. It is capable of handling millions of requests per second. Classic Load Balancer, or CLB. It is used for the applications that were built in the existing EC2 Classic environment. It operates at both connection and request levels. Features of ALB: Additional supported request protocols, HTTP, HTTPS, HTTP/2, and WebSockets. Enhanced CloudWatch metrics, access logs, health checks, enable additional routing mechanisms using path and host-based routing. Path-based provides rules that forward requests to different target groups, and host-based define rules that forward requests to different target groups based on host name. Native IPv6 support in VPC. AWS Web Application Firewall, or WAF integration. Dynamic ports. Integrates with ECS to expose dynamic ports utilized by scheduled containers. Deletion protection and request tracing. Track HTTP requests from clients to targets. Use cases of ALB. We can use ALB in many cases. They can be as follows. Using containers to host microservices and route those applications from a single ALB. Used to route different requests to the same instance, but the path may be different. ELB components. Listeners. The listener defines how your inbound connections are routed to your target groups based on ports and protocols set as conditions. For every load balancer, you must configure at least one listener. Configurations of the listener differ slightly depending on the type of ELB selected. Targets. These are the destinations for traffic based on the listener's rules. Target groups. A target group is a group of your resources that you want your ELB to route requests to. For example, to a fleet of EC2 instances. You can configure your ELB with a number of different target groups, each associated with a different listener configuration and associated rules. This enables you to route traffic to different resources based upon the type of request. Rules. Rules are associated with each listener that you have configured within your ELB. They help to define how incoming requests get routed to which target group. Now let's go hands-on creating an ALB. Before starting, make sure to decide which two availability zones you will use for your EC2 instances. Configure your virtual private cloud or VPC with at least one public subnet in each of these availability zones. These public subnets are used to configure the load balancer. Go to AWS Management Console and go to EC2. As told earlier, I have two running instances ready for ALB creation. Now under Load Balancing, go to Load Balancers, click on Create Load Balancer and select Application Load Balancer. Step 1. Configure Load Balancer. To configure your load balancer and listener, enter a name for your load balancer. Keep scheme and IP address type default. For listeners, keep the default, which is a listener that accepts HTTP traffic on port 80. For availability zones, select the VPC that you used for your EC2 instances. Step 2. Configure security settings. Here, I am not creating an HTTPS listener. Choose Next. Step 3. Configure security groups. Choose Create a new security group. Type a name and description for the security group or keep the default name and description. Choose Next. Step 4. Configure routing target group. For the target group, keep the default New Target Group. For name, enter a name for the new target group. Keep the default target type, that is instance, protocol or HTTP, and port 80. For health checks, keep the default settings. Choose Next. Step 5. Register targets. For instances, select one or more instances. Keep the default port 80 and choose Add to register. When you have finished selecting instances, choose Next. Step 6. Review. Review ALB and click on Create. You can view the created ALB. Now click on DNS name to verify. As the instance running has no content, it shows a bad gateway. This brings us to the end of this video. Summary. In this video, we have covered the following topics. What is load balancer? Difference between the application load balancer and the network load balancer. Use cases of application load balancer. Features of application load balancer. What are listeners, targets, and target groups in a load balancer? Demo of application load balancer. In the next video, we will learn about AWS Lambda.